How many of you have done a survey of different software engineering methodologies? Like the origins, waterfall, spiral, scrum, lean, kanban, any of that stuff? Ish. Okay, so we can dive in and do a little bit more around that. What I wanted to do is start to transition, because now this semester is much more oriented around building software and getting traction, doing the sort of build it and take it to market. Because last semester we sort of, as engineers, sort of tied your engineering hands behind your back and forced you not to write any code. This semester is all about writing code, getting traction. If you still haven't found a customer, you still need to do the interviews and try to find an idea. But I wanted to get you comfortable with what the different methodologies are to develop software. And then I've got a kind of a fun game to run during class. They really make that kind of come to life. Does that seem reasonable, or are you like, dude, that is so boring because I've spent an entire year studying software methodology? My guess is you maybe get one lecture in 3308 on it. Is that the issue? Okay, let me go through it. That way we're all kind of working from the same baseline here. Okay. All right, first question here is, oh, what's it doing? Sorry. We'll do this. Okay, what does Jimi Hendrix Electric Ladyland, Beatles White Album, and software engineering all have in common? Any ideas? Wacky stuff.
What was the middle one?
What's that?
What was the middle one?
Beatles White Album.
What was the first one?
Jimi Hendrix Electric Ladyland.
All the same year?
Yes, 1968. And Electric Ladyland was released, and the Beatles White Album, and the term software engineering was coined. So you may think that we are part of a discipline that dates way, way back. It really doesn't that much. If you think about the Beatles, they don't, I mean, two of them are still alive. They don't seem like they're that long ago. But what we're dealing with here is a relatively recent phenomenon. And this was, oddly enough, a NATO science committee was commissioned to think about what are we doing when we are building machines, we're building software. What is that discipline? It came from a very engineering mindset. So this is the mindset of people who have professional engineering degrees, they have certificates, people that build bridges and buildings and things like that, and said, should we apply the same discipline and rigor to the software that we're building? So they did this study group, and they recommended this software engineering sort of get together. And I think it's kind of interesting to understand the history of this. We all kind of take the word software engineering for granted. But back then it was provocative, implying that there's this software manufacturing based on theoretical foundations, there was a discipline, and then this idea that this is a branch of engineering. These are engineers doing this, even though they're not building physical things. And so they thought about, well, we should think about the design of software, the production of software, and the service of software. Again, very much 1960s mindset around engineering in general. But notice how these words still show up often in how we think about engineering. The design part, the production part, and then servicing of it. All right, so let's dig in around software engineering. What the heck is this discipline? And, of course, why should we care? Okay, the fundamental problem that we want to get at. This was from this commission report. It said, we build systems like the Wright brothers build airplanes. Build the whole thing, push it off the cliff, let it crash, and start over again. The irony about it is if you read biography, or if you read books about the Wright brothers, you get this picture of the maiden flight. I've actually seen this at the Air and Space Museum in DC. It's pretty cool. If you haven't been there, I highly encourage you to go to the Air and Space Museum. It's very cool. The reality is, though, is they were thinking about engineering in this sort of haphazard way we build software, just like the haphazard way that the Wright brothers built. And the interesting thing about it is that they were bringing this engineering mindset and saying, we need to get this right the first time, we need to build it completely, and the problem is we're just throwing it off the cliff and letting it crash. So we need more discipline of software engineers. Fundamentally misunderstood how the Wright brothers built that airplane. Flight mechanics, not engineers, they tinkered. They sort of, put some stuff together, did controlled launches. So like here, you don't see the track that they installed to do a lot of the initial controlled experimenting and tinkering. The reality is the Wright brothers were tinkerers, they weren't engineers. There was a competition at the time for a whole group of people to win a big, almost like X Prize, around first to flight. And there was one group that was incredibly well funded, and they did that. They built in perfect specification, perfect design, perfect engineering, spared no expense, and they would just like launch it off of cliffs into the water and into the dirt. Several people died doing it. So the irony is that this commission, the fundamental metaphor they used around the basis of software engineering, the Wright brothers, they completely misunderstood how the Wright brothers built the first airplane. So this might give you a little bit of insight, at least into my perspective, around how these software processes came around. So Stack Overflow, if you type in the question, what's the biggest problem with software development? The answer, lack of appreciation what it takes to build quality software. It's hard, super hard. One view into this is that it's about risk and managing and mitigating risk. There's schedule risk, there's cancellation risk, system goes sideways, defects, don't understand the business, challenges, false features, staff turners, all these things are in the mix to control. And in startup land, these are all dwarfed by the fundamental risk, which is nobody wants what you're doing. Nobody cares about the product that you build. That's fundamentally the biggest risk. The first semester was all about dealing with that risk. Now, as you de-risk a big chunk of that in the first semester, now I want to make sure you get off onto building your product on the right foot and doing it effectively. As you start to scale, there's this problem. Anybody know what this is the equation for?
Adding up sequential integers starting at 1.
Yep. What is an example where you might want to do that?
Getting more customers?
Not necessarily.
Number of connections in a graph of n versus.
Thank you. So as the number of edges grows, the number of connections grows geometrically. When it's just 2 or 3 of you as a founding team, you've got 3 people, 3 communication channels. But let's say that you get your team, like things go well, you grow to 12 people, now you have 66 connections, communication pathways that you have to manage. So now think big public company that you're taking on, an incumbent in your space, they've got 10,000 people. I'll leave that math as an exercise for the reader. The other thing that you have to contend with is when you develop software, it's easy when it's just 2 or 3 of you now, but let's say you're successful. Let's say you win a competition, you get a big seed grant, you're like, hey, let's hire a bunch of people. You suddenly get into this place where you now have to collaborate. You've probably faced this too, which is if you only collaborate asynchronously, it is not the most effective form of collaboration. So 2 people on a whiteboard is still the most effective. 3 people works pretty well. Standing at a whiteboard, this is creative work, figuring out what to do. Think about PhD dissertations, right? You're distilling down into paper form the knowledge that you have. It's really, really not effective for collaboration and communication. So think about that as you're developing software. Another big thing that software process was designed to do is deal with schedule slip. One could argue it doesn't actually slip because the estimate you gave was totally ridiculous in the first place. So it's not slipping, it's just reality is bearing down on your original estimate. But we've got some interesting ways typically that we counterbalance this. One of my favorites is Brooks's Law. If you haven't read his book, it's a fantastic book, Fred Brooks. Adding manpower to a late software project makes it later. And then he's got his quip, 9 women can't make a baby in 1 month. Clearly this is from the 70s, pretty sexist language, but the process holds, which is as you add more people to things, it makes things worse. And the typical reaction in software development or project management is let's put more people on that and get it out the door. I've got tons and tons of evidence over the years that makes things dramatically worse. got another big problem, which we've talked about fundamentally the first semester, is are we building the right stuff? So this was a survey done of, I think it was Microsoft Word, and they asked people of the like 5,000 features or 50,000 features in Word, which ones do you actually use? And the reality is that you know sort of that 80-20 rule, which is 20% of the features provide 80% of the value. Pretty close math here, which is about 20% of the features in the software people relied on, and half of them nobody ever used. Tons of waste in doing that. So what's going on here? So we've got this mindset that it's engineering. When we think about engineering, we've got this other mindset where there's math behind it, there's structure behind it, there's laws behind it. We can bring physics and science to bear on this problem. The reality is that in software we deal with something so much more squishy. And it's also pretty immature, as we talked about. I mean, you think of 68 as like a long time ago, but if you think of other engineering disciplines, they go back hundreds, if not thousands of years. So I like this definition of what is software engineering. It's solving a problem you don't yet understand while it's changing. You're creating a solution you don't understand how to build. And that solution space keeps changing and the tools keep changing. And you're writing in languages you don't completely understand. You have to translate from English into some computer programming language. That's an inherently lossy translation. So this is a challenge. So what could go wrong with that? One of my favorite charts about thinking about software development. So you've got the marketing team, got what sales ordered, what engineering designed, and then how it actually shows up. And then ultimately what the customer wanted. This is a reminder that usually what the customer wants, the final solution is way simpler than what you initially dream up for them. So fight against that urge. There's also other risks. This probably number is way up. There's a website right here that catalogs all defects that had some sort of societal consequence. Like this poor person, which their GPS got them lost and they drove into a lake, if I remember right, or a ditch. Planes have crashed because of malware in the software bus of the plane. Kind of scary. If you're not prone to paranoia, go to that website and it'll really help you out with your paranoia, lack of paranoia. Basically, you walk away from that site thinking, how does anything work? How do we not all die every time we interact with software? But there's things that can go right with this. So we know about huge entrepreneurs that have made huge success in life. So you can, in software, go from humble beginnings in a garage on the left to owning that thing on the bottom, which is the Google 767. So you can make a lot of money if you do this right. Also, understanding and contributing and understanding how to develop software that people want. This is a job rec from a company here in Boulder from a long time ago. But a lot of now what people want, not just the coding side, but the human side, the project side, and the customer intuition side. It's one of the little secrets of this class, which is every year I encourage you all to link in me. So now I can see over 5 years of doing this class kind of where everybody goes. I don't know what senior projects looks like, but the career trajectory for the people in this class is pretty impressive. First jobs, and then kind of where things end up. I don't know if you're any better than senior projects, but I've been impressed with the trajectories. I think last year we had Uber, Facebook, Google, Twitter, list kind of, I was pretty impressed with the list of places, as well as a couple of people starting companies. All right, so let's look at some perspectives on this. So this idea is the engineering faulty because the activity's faulty. Like there's something inherently broken about this. Because when we think about software engineering, there's a whole bunch of different metaphors that people have around this. Model building, engineering, it's a discipline. It's like poetry. It's got elements of math. There's a craft, there's an art to it. So there's this sense of artful making. When I think about elite engineers, elite entrepreneurs, the two things I draw on are artists and athletes. I think what we do at this level is much more like what artists figure out how to do and what athletes train their bodies to do. This is kind of the same thing I showed before. So a friend of mine, Joel, who created Stack Overflow, he makes the argument that it's not like a manufacturing process. We have this idea that this is like an assembly line. That we take this one thing and we just poop out hundreds of them over and over again. The reality is every piece of line of code that you write is generally a new line of code. You've never written a code like a module or in functionality exactly like that before. So it's craftsmanship. What he says is that this is a craft just as much as it is an engineering discipline. Okay, so let's do a survey of process. So the idea with a process is it's a systematized way to solve some type of problem. This is kind of a flowchart example of what a process can look like. Often though we think of process as a silver bullet. I remind entrepreneurs of this all the time. Stop looking for the silver bullet and just start firing a bunch of lead bullets. There's a couple of great essays on the internet about the difference between a silver bullet and a lead bullet. Probably Ben Horowitz is one of the best ones out there. Stop looking for the magic one thing that's going to make it all work. You have to do 100 things or 1,000 things, and eventually something will work. How many of you are familiar with waterfall process? Cool. All right. How many of you have written software underneath a waterfall process? I'm going to try to let my bias not come out. Bummer for you. That's my bias coming out. The interesting thing, though, is that we think of waterfall using this methodology, where we do requirements from like a system level, move it to software, analyze it, design it, a little bit of coding, a little bit of testing, and then finally operationalize it. That's what was originally described. That's what we think of as the waterfall process. The interesting thing is as it was originally described, it looked like this. Very iterative, very much a feedback-driven process. But the feedback was not around working software. It was around complete documentation. So documentation was the artifact of collaboration, not working software. That's a fundamental difference here between Agile and other modern techniques versus waterfall.